Welcome back. I know this might be a little bit late when this video uploads, but happy Christmas or a happy solstice or whatever you were celebrating, and happy new year. Yeah, another teardown. I'm sorry for that, but I was away over a week around Christmas, you know, visiting family and stuff, and so I don't have time for anything else. But anyway, what we have here are two RV042 routers, initially developed and sold by under the label of Linksys, which was later on bought by Cisco Systems, and Cisco continued making these things under its own label, Cisco, after dropping the Linksys brand. And these two have also two slightly different hardware revisions. So we will take both apart and look how these routers worked and what the differences are. Is this just, you know, penny pinching here in the Cisco version, or are they really almost identical? Enjoy! Let's do a quick walk around first, and we start at the top. Yeah, that post-it is not from me, that's from the admin, and there's a date here, 2014. And that makes sense because I know these things were used in conjunction with that DSL modem we teared apart last week or 2 weeks ago, I don't know. Card here, link in the description. Anyway, that's the older Linksys model. There is a sticker here, and this is actually stamped into the case. So yeah, some structure, and that Cisco, that's only printed on. So definitely penny pinching here. Forget about that label. That's also from the admin. It just says that here was the port to the telecom line, so basically to that modem, and that was a port to Colt internet line. Colt is a European internet provider that just sells to companies, not to private persons. LAN was connected here, and these ports, we will see at the back, they weren't used. Okay, let's have a look at the bottom. Absolutely no difference here. But for the type sticker, we have a close look in a second. But the same tempering with or disassembling this device voids the warranty sticker and the QCOK sticker and manufacturing dates. But let's zoom down and have a closer look at the type labels here. Nothing too exciting here. So Linksys, a division of Cisco Systems. So when that thing was produced, Linksys has already been bought out by Cisco Systems, and it's a 10100 megabit 4-port VPN router, model RV042 version 1.1. Serial number, MAC address, and the manufacturing date, which is month 8 of 2007. DC input 12 volts, 1 amp. And here the type label of the now pure Cisco thing. Everything Linksys is gone. Everything's the same. No version, no mentioning of the hardware version here. But I saw it somewhere. Yeah, here. It's the RV042 version 03. So, I don't know, 1.3, they changed the versioning scheme. We will see. And that was made in month 6, 2014. So yeah, there are a good 7 years between the two units. The front plastic mold is almost identical. They changed, of course, the color from Linksys gray to Cisco black, and penny pinching. They got rid of this thing that's glued on here. Just out of an interest, did that really... sorry. Yeah, that was an additional feature in the mold of that plastic piece that they got rid of. Otherwise, they're completely identical. So they really reused the mold, just simplified it. That is, filled that gap up again. The sides are also identical. Kensington lock here. And the other sides are also identical. Here, the plugs for the external power supply, 12 volt, 1 amp. We already saw that on the type labels. The back side is also identical. I think these are reset switches. Yeah, reset switch. 4 Ethernet ports, switched for the LAN. 1 internet port. Not a modem inside here. Okay, so this is just talking TCP/IP. And yeah, you could configure that either as a second internet port, so you had either load balancing or fail over if one of your interconnections wasn't working anymore. So yeah, we saw at the front labels, they were used on 2 different internet providers, Colt and German Telecom. Or you could use that port here as a demilitarized zone. And these ports not only could speak TCP/IP, but also some, we already talked about that, modem protocols over Ethernet. And now let's try to crack those things open. The only screw I see right away is that little Phillips screw here. And it's identical for both. And it's not a self-tapping screw. It's actually a real screw. Sorry, hand is in the way. So that's good. And now we can probably, yeah, get rid of these labels here. And open these things up. Maybe. Oh, that's it. Single screw holding the back. It works exactly the same on this side. And we already see the boards. And these are mounted, if I see that right, you probably can't see in here there, by screws under the feet, of course. Or not. Do we have here the first real difference between the two? I don't know. No. Maybe we can just... No. Okay. How the hell did they mount that? Give me a sec. Or maybe... No. 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 Okay, now I'm getting a little bit desperate. Oh, I see how that works. These things should, can you see that here? There's a little hinge here. So we need to remove the front plate first. And that makes absolute sense that the front plate might be snapped on. A cluck. I don't know if that was destructive or not. No, was not destructive. Okay, let me do the same thing for the other unit. Okay, these are again identical, down to, as far as I can see, down to these part numbers here. Let me zoom down to these. So identical part numbers, you can see the part number here, and it's the same for that one. So they didn't change anything. Yeah, just 1, 2, 3, 4, 5, 6, 7, 8, 9 light pipes for the LEDs. Okay, let's put that away. And now, if I was right, you should be able to just flip them open. Or not. Is that welded shut? No, can't be. Maybe the older one is easier. Sorry, I'm a little bit out of the picture. I'm trying by looking inside here to see what's going on. Maybe spot welded. No, this should come apart. Ah, okay. I think I got it. You have to press in here a little bit. Then it should come apart. Oh, that's hard. That's hard to... I don't know how to do that. Let me think about this problem. If you look closely, you see that that hole here, that's the front, and where was it? That hole here, yeah, they look a little bit different. That's because a metal tab was pressed in here with some tool, and that holds both sides together. Yeah, let's see if we can open it anyway without a destructive force. I'm actually not sure if I just lost some footage that is respectively forgot to press record, but I got one of them apart. It's the same case, so enclosure. So we do the same here, and if I remember right, it was just, we can do this again, maybe from here, just press the whole thing a little bit back. So it's not really a hinge here, and then it lifts apart. It's just a little, yeah, metal snap-in thing that goes here somewhere and produces some, yeah, friction. That's it. And here we have both. So that's the Cisco version, which is significantly different. That's the Linksys version. Okay, and there are labels. So let's have a look at the labels. So this is not very interesting, just some serial numbers and manufactured for Cisco, so not made by Cisco itself. And it says here on the board 3000 RV042 G90. The older Linksys version also has almost the same label, 3000-RV4241, but G40 instead of 90. And also some, G40 sticker here. Oh, wait a second. That was a G10 for the younger Cisco version. Both mainboards are held in by 4 beefy Phillips screws. Real screws, not self-tapping. That's nice. And Cisco actually gave them, or invested in 2 additional washer on each screw. Okay, there are some rubber bumpers, or are these... No, these are not for heat transfer. These are just for giving the board a little bit of space here. Okay, let's have a look at the boards. Just for orientation, that is the Cisco board, the more up-to-date board, and that's the older Linksys board. And what you immediately notice is that there was obviously an optional board here that could be mounted in the Linksys version, and yeah, Cisco got completely rid of that. We obviously have a different main processor, I don't know, type that does the actual routing. This is probably be memory, and this is also missing, or maybe replaced by that chip here. So here's the intelligence happening. Then we have coming in from the Ethernet side, we have here two 4-port Ethernet transformers. Formerly, the older version provided by Delta, and that's a Taiwanese brand. We already saw these thingies, that brand in that teardown, already carded, link in the description. That's both hands. So they changed out the Delta transformers. I don't know if these are really Deltas, but they look like it, with both hand transformers. Well, okay. The power supply section, we have here obviously one switch mode power supply, and this might be a linear regulator, and then a really, I guess, big linear regulator here, and this has all been replaced by 1, 2, 3 switch mode regulators. I don't know if that was really cheaper than that setup, but they had their reasons. It was probably cheaper. Otherwise, I don't see lots of difference. Yeah, this is an Infineon chip here who does probably do the hardware things of the Ethernet side, and this has been replaced in the newer version by a Realtek chip, and yeah, that's it. So you see, I would like to say less components, definitely less chips here, cheaper stuff, of course. Yeah, definitely less chips, and they went from one switch mode plus maybe 2 linear power supplies regulators to 3. Let's have a look at the backs. The Linksys version has absolutely nothing, only some passives here on the back, but it has 2 conductive pads here to make real good contact to the enclosure. Just, yeah, to get rid of that electromagnetic interference and stuff. And yeah, who needs that shit? What's a little bit electromagnetic interference between friends? Cisco, what have you done? And yeah, 2 missing chips. I guess these are just supporting our memory chips for the processors on the backside. So actually the the additional memory chips missing here on the Cisco model. This is probably here, that's the lattice. Lattice does memory? That lattice is mostly FPGA. Oh, we will see. Maybe that's the memory. Whatever. Okay, it's time to have a closer look at the boards and the chips. So, Ethernet transformers on the Linksys version, no surprises here. Delta LFE 8731, that's an Ethernet transformer. Delta calls that for some reason LAN filter for 4 transmit-receive pairs, you know, twisted pair Ethernet. And these are also Delta, both the same, LFE 8563, and these are Ethernet transformers or LAN filters containing transformers for just 1 transmit pair and 1 receive pair. On the Cisco version, we find, of course, we already saw that, also 3 Ethernet transformers, and the big one is from both hands, 40SS1041AXHF, and both hands calls those pulse transformers. Not filters, but transformers. And of course, that one contains enough transformers for 4 RX and TX pairs, and the smaller ones, the TS8121CX HF, only for 1 transmit pair and 1 receive pair, RX TX, TX RX. Yeah, and I had to flip the Cisco board, otherwise we couldn't read the numbers here. On the Linksys board, all the transmit and receive pairs are all going to that Infineon chip here. And that's a chip from the ADM6999 family. There are many variants of that. They are all long obsolete, but basically that's a 10100 megabit 9-port switch that supports VLANs. And you remember we already have 6 ports here, so 2 WLAN ports and 4 switched LAN ports, so that's 6 ports for 2 WLAN connections and the LAN connection. And so I strongly suspect that we have a total of 3 Ethernet ports going here to our router processor. And while we're at it, we have here 2 more chips. That is in fact 3 more chips, because that is marked U10 and I haven't found anything about it. 690BD or 690-8D or 690-80, and I strongly suspect that this is a voltage regulator, linear one. Then we have here the C7703I from Texas Instruments, and that's a supply voltage regulator with built-in reset function that obviously gives a reset signal or low voltage signal to our big processor down here. And then we have a run-of-the-mill 74 LVC04AD. Well, not quite run-of-the-mill. That's a hex inverter that usually runs on 3.3 volts, I think, but it has 5 volt tolerant inputs. Okay, let's move over to the Cisco board and look at the same section. And there we find above our Ethernet transformers or filters or whatever, an Realtek RTL 8309G. That's also a 100 megabit 9-port switch controller, I guess also with VLAN capability to make here 4 ports for the local LAN and 1 port from the local LAN to the controller, and then 2 ports each for connecting the 2 WLAN ports to the controller. So yeah, none of that overpriced Infineon rubbish here on the Cisco version. And if we go a little bit up, yeah, 1 additional chip. I don't even bother. That's a voltage controller, I guess. Nah, it's a DH90H, and I have nothing about that number. But I guess also it's a voltage monitor reset controller for the processor further up. And further up, the core of the whole thing has a heatsink on it, but that shouldn't be a problem. It's only held down by 2 pins here that are soldered into the board. I think I can snip them off. Give me a second. So 1 snip here and 1 snip here, and yeah, have to clean off this. Well, it's not, yeah, it's a pad. Yeah, this might take a while. I'm not going to film that. Okay, I had to turn the board around again so we can read the stuff. Here was our Realtek switch controller. Here's our mystery chip, and now for the big finale. Well, not finale, but the high point. So at the heart of the Cisco version is Cavium Octeon Plus. Never heard of that company. I think it's no longer in existence. These processors came out in about 2008. So yeah, quite old chip to use in that setup here. And to be exact, it's CN5010. So a single core MIPS 64 CPU, and then 300 megahertz, and BG564. That's just the packaging. And then I don't know what the -SCP-G stands for. But yeah, single core 300 megahertz MIPS 64 CPU. We're back on the Linksys board. Here is our Infineon switch controller, and the core of the whole thing is an Intel PRIXP425BB, and that's a dedicated network processor with an X-scale core, so ARM instruction set, 32 bits at its core. And it can run at 266, 400 or 533 megahertz. Let's see if I can find the quartz. And here we have the two quartzes. 25 megahertz, that's probably here for the Infineon switch controller. And that 33.33 megahertz thing, that's actually here for our little Intel network processor. The problem is the Intel network processor has an internal PLL circuit that is multiplying the frequency here. And we can only guess at what setting it is. So I really can't tell you if that thing here was running with 266, 400 or 533 megahertz. Sorry about that. And going from that edge of our processor, network processor, to that edge, we find again an Intel chip, GS28F640. There is a dash missing, G3D75. So that's a 64 kilobit flash, accessible either by a 8-bit or 16-bit wide bus. Yeah, and the 75 nanoseconds access time. And they put a label on here. So I guess they pre-programmed the flash chips before they were soldered onto the board. Interesting approach. Had to turn the board again. So yeah, here our Intel network processor, our Intel flash, and then moving over here, we find two Hynix HY57V281620 ETP-6. And these are obviously DRAMs, 128 megabits each and with 16-bit buses. Yeah, I think there's one chip left here. If we go up here, and yeah, I guess we can read that. Let me refocus on that. Well, hopefully good enough. So, well, not too good. It's a Nexperia LVC374A, so 74 LVC374A. And that's an octal D-type flip-flop with 5-volt tolerant inputs, so just some glue logic. We're back on the Cisco board to look here for the supporting chips for our processor here, and I had to turn the board again. I'm sorry, but the next chip here is an Intel. Well, the first big brand name chip, I mean Realtek, real And it's a JS28F. We already saw that on the other board, but this time it's a 256. So a 256 megabit flash with an access time of 33 nanoseconds. And yeah, this thing, yeah, it's the same family. It also supports either 8-bit or 16-bit bus connection. Turn the board again, and moving around we find that little beauty here. And it's really a little beauty. That's a Samsung K4 T51163 Q7 BCE7. Yeah, that's actually a 512 megabit DDR2 800 DRAM with a, well, you guessed it, 16-bit interface. So Cisco did quadruple the flash memory and doubled the RAM in, yeah, maybe as compensation for using that really cheapo CPU here. I don't know if it's really cheap, but it was definitely cheaper than the Intel Jobby. But wait, the Cisco board also had two more chips on the backside. The smaller one is again the same Samsung DRAM chip. So we have a total of 1 gigabit of DRAM on that board. So we also quadrupled not only the flash, but also the RAM in that version. And the big one here, that's a Lattice LCM XO25, and yeah, something wrong with the print here. That's a 6C-3TN100C. That's an FPGA with 256 logic elements that you can somehow cobble together to do something. I'm astonished to see that. Maybe some functions of that Intel network processor we saw in the Linksys version could not really be done by the universal Cavion MIPS core processor, and so they needed a little FPGA to compensate for that. Now let's go over the power supply sections of both boards. We're starting with the Linksys, and we see here, is that a Q there? That's a Q. 1, 2, 3. That's also a Q. 4 chips. What can that be? Linear regulator? I don't know. One thing is clear, there's only one switch mode regulator here on the board. I found absolutely nothing for that little bugger here, BHR not Q. Linear regulator, probably, maybe a PNP transistor or NPN transistor, so bipolar, but I'm really not sure. That thing beside it, and yeah, I had to rotate the board again, that's 34063. That's a switch mode controller, a universal one, buck, boost, inverting, whatever needs to be done. Okay, that was a switch mode controller, and that 9435GM here is in fact a P-channel power MOSFET. So I guess that controller doesn't have a power MOSFET integrated. And it's marked Q2, but yeah, it's really just one single MOSFET. And then we have that 1AM, and that's also a transistor, but a bipolar one, an NPN transistor. Yeah, that's it. Almost. So we were looking here, but we have another FAT, and I guess that's a linear voltage regulator here at the edge of the board. And that's a Nikos for Nikosem L1085S3G. So that's an adjustable low dropout linear regulator. So no surprise here. As we've already seen, the Cisco board makes 3 power rails through 3 switch mode converters. So let's have a look at these 3 chips. And those are MPS MP14A2DSs. So these are synchronous rectified step-down converters. So yeah, all active components are inside that package. MOSFETs for the switching and stuff for, well, another MOSFET, I guess, because it's synchronous rectified, for rectifying. You can add, that's mentioned in the datasheet, an external Schottky diode in parallel to one of the internal diodes of the MOSFETs to increase efficiency. But yeah, obviously it's here on the board, but they didn't populate that, at least not here. So let's move over slowly to the next one. No, not populated. And the third one, no, not populated either. So yeah, obviously they were efficient enough without the optional Schottky diode. But it's a nice chip. I mean, really, you only need some passives around it, and you have a step and an inductor, of course, the big thing here. And you have a step-down converter. Great. That's it for today. I must say I'm a little bit astonished that the, compared to the old Linksys version, the newer Cisco version is really almost a complete redesign. Okay, so yeah, the front end section here with the transformers and the switch controller, that's pretty identical. But the rest, the power supply and the processing itself, or the router, it's completely different. It's really completely different. It's a new board in that sense. Next time we will, I don't know. I still need to catch up now with work after all these holidays. So I fear it might be another teardown. Anyway, till then, bye.